Hey everybody, this is Miss Doolittle, and this video is going to help us. It's actually going to be a reminder. We went over this in class a little over a week ago. I guess that was it's been 2 to 3 weeks ago now, but briefly touched on identifying polynomial functions, and I just wanted to do a short video to walk us back through that, just in case you need a little refresher. All right. So here we go, a definition of a polynomial. So remember, I don't know if you guys remember this, but I have got this slide an absolute mess, okay? And it took us a really long time to get through it. The first time, I'm gonna try to shorten that quite a bit. So we're gonna go to a clean slide here. This is the big, long, scary way of looking at a polynomial function, okay? This is its actual definition, but really what it means is something like what you see down below, so right here. Okay, so f of x equals 4x to the 5th power. So we've got these things called coefficients, okay? The coefficients, so we've got a 4, a -2, a +13, a +3, a -1 that we can't see, but it's still there, and a +7. All of those are coefficients. Those are all our a values that you see up here. So the a sub n minus 1, and so on and so forth. All of those correspond to these numbers that I've underlined down here. Okay, so all the a's are real numbers. That's the main thing you need to remember. So my coefficients have to be real numbers. I can't have imaginary number coefficients, okay? Now, of course, we have a variable. Our variable is x in most cases. It's going to have to be the base for my exponent, and you'll see that that's the case here. So x to the 5th, x to the 4th, x to the 3rd, and so on and so forth, okay? Now, we also have all these n values up here. So n and n minus 1 and n minus 2 and so on and so forth. Here's what you need to know about that. That part gets really important. So n is going to have to be a non-negative integer. Now we talked about this before. What that means is it cannot be a decimal or a fraction. Okay, so you're not going to have a decimal or a fraction as an exponent. You are also not going to have a negative value as an exponent. Okay, so no negatives, fractions, or decimals as exponents. Okay, those are going to be your exponent values. All right, all exponents are whole numbers, so that again talks about it not being a fraction or a decimal. Our leading coefficient, what this one is talking about is our leading coefficient. Our very first coefficient cannot be a 0. Now other coefficients can be zeros, but not our very leading one, okay? And then the other big thing that you have to know is that n, the highest exponent, represents the degree of the polynomial, okay? So for instance, this particular thing right here is a 5th degree polynomial. And that polynomial, or that degree, might be written out in front. That's the nicest way for them to write them for us. But we have to scan across whatever polynomial function we might be looking at and look for that highest exponent term, because the highest exponent does tell us the degree of the polynomial. Okay? All right, now we talked about this really briefly as well. If we can have a 0 degree function. That would be a constant function, because remember, this is the same thing as c times x to the 0 power. So this would be something like f of x is equal to, let's say, 5. That's what the c represents, is just a plain old constant, some number, right? And its graph is going to be a horizontal line. You've been working with linear functions forever. That is actually a 1st degree polynomial. So this might be f of x is equal to 2x minus 4. All right, that's a linear function. Slope is m, y-intercept is b. That's old news to you guys. In this case, this is a quadratic, so a 2nd degree polynomial is a quadratic function. That could be something like 3x to the 3rd squared, we're working with a quadratic, plus x minus 5. That would be an example of a quadratic, okay? Now, once we get higher than that, we're just simply going to call them polynomials. A 3rd degree technically could be referred to as a cubic function. And sometimes a 4th degree is referred to as a quartic function. But often Anything higher than a quadratic, anything higher degree than a quadratic is just going to be considered a polynomial. Poly means many, right? So at that point, they're just calling it a polynomial and calling it good. Okay. Now, next thing we're going to look at here are some examples. We are trying to determine whether or not these things are polynomial functions. So if you guys would like to pause the video, you certainly can, but I'm going to go ahead and walk through these at this point. The video will play through once you push play again. So if you want to push pause and work these out, go ahead and do that now. If you would rather not, then stay with me and we'll go ahead and work through this now. Okay, so here's the situation. In this case, this could be written, you don't have to rewrite it this way, but it's negative 2x to the fifth plus 3, right? The negative lives with the 2x to the fifth. It has to stay with that value. So this is all of our coefficient and our constant. Those are real numbers, and we only have one exponent here that's showing at least, and that one exponent is definitely a non-negative integer. So we would say yes, this is a polynomial function, and it also asks up here for the degree of the polynomial. This is a fifth degree. Okay, now on this one, I don't know if you guys remember this. I'm thinking you probably did this in Algebra 2, but I'm not sure if you remember it or not. This would be the same thing as x to the 1/2 power when you have a radical over the variable. That radical is going to transform to a fractional or rational exponent. Okay, so because we have a fractional exponent, we are going to say no, this is not a function. And then we can't give the degree because it's not a function. Okay. All right, part C, g of x equals 2. Remember, this is the same thing as 2 times x to the 0 power. All right, so that means this is a polynomial, and it is a 0 degree. Okay, part D. In part D, this is a polynomial, second degree. Now part E gets a little bit more complicated. What you have to look at on this one is if I were to multiply this is just already broken down into factors, okay? So to get the degree, we would have to multiply all that stuff through. But before you get stressed out about that thought, keep in mind that really all we need is that highest degree term in order to determine the degree of our polynomial, okay? So at this point, I don't see anything that's going to make me think that I'm going to have any fractional or decimal exponents, right? I also am not going to have any negative exponents. The only exponents I have here would be the 5 and the 2. So what this would work out to be is 4x to the fifth times 2x minus 3 times another 2x minus 3. Now, I could have you guys completely FOIL 2x minus 3 times 2x minus 3 and then multiply through with the distributive property, the 4x to the fifth power. But the shortcut to this is, how do I get that highest degree term, the leading term? Well, if I multiply this times this times this, that is going to give me that highest degree term, okay? So 4 times 2 times 2, that's basically 4 times 4, or 16, and then x to the fifth times another x is x to the sixth, times another x is x to the seventh. And I'm going to have all kinds of other stuff that would follow that, right? Because once I multiply this out, I'm going to have all kinds of things. But all I really need is this component. So I do know that I'm just going to have non-negative integers for exponents. So I'm going to say, yes, this is a polynomial function. And because I have worked out this leading term, I can say that it is a 7th degree polynomial. All right. All right, and part F. In part F, as we look across here, I have an exponent of 4, which is good, an exponent of 3, which is good, but then I get to this exponent of -1, which is not a non-negative integer, it is negative. So I'm going to have to say that no, this one is not a function, okay? All right. Okay, so I am going to go ahead and have you guys take a look at one more slide. And I'm going to see if you guys can determine whether or not These are functions. I'm going to give you a hint before you get started. So this one could also be written as f of x is equal to x to the negative first power plus 2. Remember, when you have something in the denominator, we can accommodate that by writing a negative exponent, okay? So go ahead and press pause and see if you can get these two figured out. Okay, and hopefully you had a chance to get that worked out. Of course, this first one, we have a negative exponent here, so all of our exponents are not non-negative, which means we have to say no, this one is not a function, okay? Now, part B, that is similar to one of them that we did on the last slide, and that's the one where the easy way to do this is just to multiply all of your leading terms together, keeping in mind that we're going to be raising this to the second power and this to the third power, and then multiplying all those when we're done, okay? So it looks like we are going to have all non-negative integers for exponents. So yes, I'm going to say this is a polynomial function. And then if I take 3x to the 8th power times this x squared, remember this is the shortcut here, and then take that times x cubed, it's not going to give me the full polynomial, but it will lead me to that initial term, okay? So that's going to, x to the 8th power times x to the 2nd power is x to the 10th, and then times another x to the 3rd is x to the 13th, and of course that 3 in front is going to remain there. So that's 3x to the 13th, so this is a 13th degree polynomial, okay? Now remember, we could have multiplied out the whole thing. If we were trying to get the full polynomial, that is what we would have to do. But in this case, we didn't have to do that. All we needed to figure out was the degree. So that's the reason I took the shortcut. Okay? If you have any questions, let Mr. Sickmiller or myself know. Thanks for watching, and we'll talk to you in class. Bye-bye.